Hello, everyone. We will continue the series of lectures on Introduction to Data Science. Today, we start with NumPy array attributes. So here in this cell, let me first import NumPy as MP. Okay. So here we are creating one-dimensional array. Okay. So as we have already explained it, so here we are choosing a fixed seed. That's just for the reproducibility. So if we run the cell again and again, we are generating the same random values. So here we are creating a NumPy array, 1D, one-dimensional NumPy array. So the elements are random integer in the segment between 0 and 10. Since we didn't specify the starting point, then our starting point is 0 and the ending point is 10. So we are generating random zeros, random integers between 0 and 9. And the size is equal to 6. So the total number of elements is equal to 6. Okay. So now we are printing these three things. These are attributes for the NumPy arrays. So as it's also specified here, okay, we have the number of dimensions in dim. That's the first attribute. That's the number of dimensions. So for this array, it's 1D array. So the number of dimensions is equal to 1. We have the shape, okay? That's the size of each dimension, okay? So here, the shape, this is an interesting one. When we print out the shape, I will talk about why, like what we get is what we see later on. And the size here, the size is the total number of elements. It's clearly from here, the size is equal to 6. So if we print this out, this is what we get. This is the array. It's randomly generated from numbers 0 to 9. So as we expected, so the number of dimensions is equal to 1. But look at the shape. The shape is 6 comma nothing, okay? Why is that? Because this is 1D array, okay? There is no notion of rows and columns here. There is only one dimension here, okay? And the number of elements in that dimension is equal to 6. And the size is equal to 6. For example, if we do it this way, if we do 1 comma 6, okay? This is 2D array, okay? So this is a 2D array, but it has only one row. So compared to this, we will have outsider brackets. So we have brackets for the array, and then we have inside the brackets for the first row. So it's a 2D array, but it has only one row. If we print it out, this is what we get. You see, there are these outside brackets for the array, and this is the first row. Now, after we added this one here, it became a 2D array. So the number of dimensions is equal to 2. Okay. And the shape is 1 by 6. Okay. So we have one row and we have 6 columns. And the size is equal to 6. The size is the total number of elements. Okay. If we do it this way, 6 comma 1, then the only thing that changes is the shape, right? So this also in the printout, so every element will be in a separate row. So every element will be inside brackets. Okay. The first row has the element 5. The second, let me print it out. This is what we get here. Okay. So that's the first row, second row, and so on. So the number of dimensions is equal to 2. Okay. And the shape is 6 comma 1. 6 rows and 1 column. And the size is equal to 6. The total number of elements is equal to 6. Okay. So now let me fix this. Okay. So now here, this is what 2D array. We have already explained explained here in this cell. So here we are generating a 2D array. Okay. So this is a 2D array. Now the number of dimensions is 2. Okay, because we have 2 dimensions here. We specify 2 dimensions. And the shape is 3 comma 4. We have 3 rows and 4 columns. And the size is the total number of elements which is equal to 12 elements. All right. 3 times 4. Okay. Now we come to the indexing. For the 1D array, the index is same as we have as the indexing we use for Python's lists. However, if we go to 2D array, okay, for 2D array now and 2D list, the indexing is different. So look at this here. So if we are indexing a 2D list, then we pass the first index inside a pair of brackets, and then the second index inside another pair of brackets. But for arrays, the two indices inside the same pair of brackets, and they are comma separated. Okay, so let's here we are generating a 2D list, and in fact, a 2D list is a list of lists. It's not really rows and columns as we show here. So here, what we are doing for this one. So for this goes from 1 to 3. We are generating 4 elements. So we will have list of lists where for each list there are 4 elements. Okay, we have 3 lists. This is 3 lists. This is the list 1, list 2, and list 3. And for in each one of them we have 4 elements. So now if we are interested in this element, we will use 0. 0 refers to the first list, this list, and then that's the first list, and 1 is the second element here, because 0 here refers to the first element. Okay, this is the second element to access that element. Now if we write this way, 0, 1, we will get an error because that's not the way we index 2D lists. Okay, now we come to 2D array. Okay, so we are generating 1D array. Okay, so here we have 1D array. Okay, the same array we generated previously. Here we are just printing out the indices, and here we're calling the function toList. So note that x1 is an object. Okay, it's from the numpy class. So all the functions for that class are applicable to this object. So it's an instance from that class, from the numpy. So now we're calling the function toList. Okay, the function that is inside the object here. So this function will actually create a list from the elements of x1. x1 still going to be an array. It will not change. Okay, so this conversion is not permanent. So x1 is still an array, but we are creating a list from the elements of that array, and we are printing them out. So this is what we get here. Okay, these are the elements. This is the array. We are creating a list from those elements, and we print it out here. So we print out the values, and here we are printing out the corresponding indices. As you can see, it still belongs to the class numpy array. Okay, so now we can access different elements here. Okay, x1 of 0 will be 5, the first one. x1 of 4 will be which one? The one with index equal to 4, which is the fifth element. So 0, 1, 2, 3, 4. So the printout for this will be 7. x1 of -1, this is now we're going in the reverse order. So this is going to print the last element, this one. Okay, x1 of -2 will be the one before the last, this one, 7. This is what we get here. You see, this is the last one is 7. This is 9, as we said, and so on. Okay. Okay, now let's generate a 2D array. So we have this 2D array. We have 3 rows and 4 columns. And now let's access different elements there. So x2 of 2, 1. So 2, 1, it's this element, right? So this is the 0th row, first row, second row. So this indexing the row. So this is the second row. The row that has the index 2. It's the third row, actually. Okay, this is row with index 0, row with index 1, row with index 2, which is the third row. It's this one here. And this one refers to which column? This is the column with index 0. This is the column with index 1, the second column. So the element we are printing here is 4. Okay, let's look at that. Yeah, this is 4. Okay. Now, x2 of 2 and 0. This is the row of index 2 and column of index 0. So it's 2. Okay. Now let's look at this x2 of 2, row 2. This is row of with index 2, the third row. But for the column is minus 4. So the last one is minus 1, minus 2, minus 3, minus 4. This is minus 4. So the element will be 2. Okay. X of minus 2 and minus 3. So the rows, we start from the back. So this is minus 1. This is minus 2. This is the row with index minus 2. And the column with index minus 3. Minus 1, minus 2, minus 3. It's the element number 9. Sorry, the element with value 9. Okay. Now, if we come back to the x1, okay, remember x1 is of type integer because it was generated using rand int. Now we are passing a floating point number. So this is how actually any number you pass will overwrite whatever is there, the existing one, but it has to follow the type. So we are passing a floating point number, but this array can take only integer numbers. Therefore, this number will be rounded to the nearest integer, which is 3. Okay. So the first element, the element with index 0, now we have replaced whatever there with the integer of this one, the integer transformation of this one. Okay. Here, if we want to update the first element of a 2D array, we just pass, this is 0 for the first row, 0 for the first column, and we override the existing value with this one. So the first element will have a value of 12. Okay. Now we come to slicing. Slicing refers to selecting or extracting a subarray from a given array. Okay. So let's see that by examples. So here we generate 1D array. Now we know all of this. We have done that. So here we are extracting. What are we extracting here? Okay. So maybe let's look at what we want to do and see how we did it. We are displaying the first 5 elements. So we are extracting only the first 5 elements. So we start from the 0th element. This is x1 from 0 to 5. But since the starting point is 0, I don't need to write it. Okay. So x1 of from 0, I don't need to write 0 since if the starting point is 0, if I'm starting from the beginning, I don't need to write the 0. Colon. So now I need the the first 5 elements. The first five elements are the elements from 0, from the one with index 0 to the one with index 4. 0, 1, 2, 3, 4. These are the first 5 elements. So then we need to pass the index 5 here, because Python will not take the one with index 5. So in this notation here, Python actually, if I write it like from 0 to 5, so we'll take the first, the starting point. It's inclusive, but the last one, it's not inclusive. So the starting is inclusive, the ending is not inclusive. So the element with index 5 will not be taken. So if I need the first 5 elements, I go from 0 to 5. Then I extract the first 5 elements, which are the elements from 0, from the one with index 0 to the one with index 4. Okay. These are the first 5 elements. Now, if we need the last 5 elements, display elements from index, not the last, display elements from index 5 to end. So we want to start from index 5. If our starting is not 0, then we need to specify it here. Our starting is 5, we need to specify all the way to the end. Okay, then we don't need to specify the end, just 5 colon. Okay, now we're going to start. Now this is inclusive because that's the starting point. Okay, so we're going to go all the way from the 5th, the one with index 5, okay, to the end. Okay, this is the one has index 5, all the way to the end. Okay, now if we want to display elements from index 4 to 6, the starting point is the one within the element of that has index 4, and the ending point is the one that has the index 6. So then since the ending is not included, okay, then if we put 6 here, then we're not going to consider the one with index 6. We're going to go, if we put 6 here, then we will print out only the one with index 4 and the one with index 5. So if we need the one with index 6, then we need to go to 7 here. We pass 7. Okay, the one with index 7 will not be included, but the 3 elements, the one with index 4, 5, and 6, will be printed out as we see here. Now, if we pass this, the starting is the same as the ending. Okay, we start from 5 to 5. Okay, the starting will be included, but actually the starting is the same as the ending. So the ending should not be included. Then we will have an empty array. Okay, so now display alternate elements starting from the first element. So we want to start from the first element all the way to the last element, but we want to consider every other element. Okay, so we're going to skip, like we're going to, yeah, we're going to consider every other element. So we're going to skip one element every movement. So then, since from the beginning all the way to the end, then we don't need to specify the beginning, the starting point. We don't need to specify the ending point because we are going all the way from the first to the end. So we have first colon. We don't need to write anything before that colon. We don't need to write anything before the second colon. But now we need to specify the step size. We use not to, if we are going all the way from the beginning to the end, then we can do it this way. Okay, then we are printing all the elements. We don't specify the start, we don't specify the end. If the step size is 1, if every time we go 1 by, we go to the next element and so on, then we don't need to specify the step size. Okay, the default step size is 1. But if I want to go every other element, then I need to specify the step size. Okay, then I need to add this, the third component here. So with this one, we're moving from the beginning all the way to the end, but we are considering every other element. So we're skipping one each time. So we start from the first one, we go to the third element, fifth element, and so on. Okay, now display alternate elements starting from the second element. We're not starting from the first element. Then we just need here to pass the index of the second element, which is 1. So we're going from 1 all the way to the end with a step size of 2. Okay, so as you can see, compared to that, we're starting from the second element. This is actually skipping these elements. Okay, because this was second there, it was skipped. Okay, display elements starting from fourth element from the end and ending at the last but one element. Okay, so we're gonna go all the way from back. Wait, no, we're gonna start from the fourth element from the end. So now we are going in the reverse order. From the end, we're gonna go to the fourth element. Okay, so then we're gonna go to -4. Okay, so because now we're going in the reverse direction. From the last element, go to the one that is 4 from the, if you're going backward, it will the one that is the fourth one. So it's -4. Okay, all the way to the, not to the last one. Don't include the last one. Okay, ending at last but one element. So we don't want to include the last one, and the index of the last one is -1. So if you pass that, then because this is not inclusive, so we're gonna go all the way from -4 to the one before the last one. We're not gonna include the last one. Okay, here the last one is 4 here, so we stop at 2, and we're starting from 3 because -1, -2, -3, -4. This is -4. Okay, display all elements in the reverse order of indices. That is simple. So colon -1. If this was 1, in fact, we don't need it, right? We could have done it this way, right? But now we are starting from the very back, okay, we are starting from the last element. So we don't need to specify the index of the last element all the way to the first element. We don't need to specify the index of the first element, and we are going in reverse direction. This -1 tells us that we are going in a reverse direction. So if this is 1, then this is actually, we're going in the same order. But now this is -1, we are flipping the entire array, okay? And in fact, I can also specify that I'm going from the last element. Since the starting is inclusive, it's still gonna give me the same result, okay? Now let's do the same for a 2D array. Okay, now we're generating this 2D array. We have 3 columns and 3 rows and 4 columns. And what we have been doing for 1D array, so we will do it per coordinate here. So we will do it for the indices of the rows and the indices of the columns. So the idea is same. It's just like we're gonna do the same thing for every coordinate separately. For example, here we display first 2 rows, first 2 columns. So we start from the beginning. We are not specifying the beginning, okay? We're not specifying, we're not passing any index here. We're starting from the beginning all the way to the 3rd row, right? So the first row has index 0, second row 1, third row 2. So we're going all the way from the beginning to the 3rd row, and for the columns all the way to the 4th column. Okay. Yes. So yeah. Wait. No. Sorry. I said something wrong. So 2 is not included, right? 2 is exclusive. So we are actually starting from the beginning all the way to. So we're considering the first 2 rows. Okay. The row with index. So the row with index 0 and the row with index 1, because the row with index 2 is the 3rd row, and 3rd row is excluded. And the same thing here. So the 4th row is not included. Okay, the 4th column, 1, 2, 3. So here 1, 2, 3, 4. There are 4 columns. So we are considering only the first 3 columns because the ending should not be included. So the same thing we did for 1D array. Sorry for the confusion. Okay, now we come here. Display all rows and every other column. All rows from the beginning all the way to the end. All the columns, but move with a step size of 2. Display every second column. Every other column. Okay. So then we will display the first column and the 3rd column. This is the first column and this is the 3rd column. Okay. Same thing here. Display all rows and columns in the reverse order. So we don't specify the beginning and the end because we are going all the way from the very back to the first row in a reverse order. We are passing the step size here is equal to -1. So we're going in rows in reverse order as well as in columns in reverse order. Okay, so we're reversing all the elements, rows and columns. Here we are displaying the first column. The first column has index 0. So since we are displaying all the elements of that column, then for the rows, we pass colon. So display all the elements from the beginning all the way to the end. Okay. Here we're doing the same, but for the first row. First row, which the row has index 0 and all columns. Okay. And yes, that's. Now these 2 are interesting ones. So display 3rd row. So display 3rd row elements in order of column 3, then column 1, then column 2. So this is the 3rd row, the one that has index 2. But we are displaying the elements, the columns of that in a specific order we specify. So if I want to change the order, this is the way I do it. So I need to pass the order inside brackets, comma, separated indices of the columns. So I want the third column to be first. The index of the third column is 2. And the first column, second, the index of the first column is 0. And then column 2, the column 2 has index 1. Then comes the last column. So now I'm changing the order. I'm displaying the second row, only the second row, but the columns, I'm changing the order of the columns, changing the order of the elements. Okay. Here, display second and following row elements. So from the second all the way to the end, second and following row elements in order of column 3, then column 1, then column 2. So this is going all the way from the second row. Second row has index of 1. From second row all the way to the end. But the order of displaying the columns has to follow this order. Column 3 first. Column 3 has index 2. Then column 1, which has index 0. And then column 2, which has index 1. I want to display only these. And in this order. I want to display column 3. Okay. I want to display column 3. I want to display column 1, column 2, column 3, but in this order. Column 3 first, column 1 second, and column 2 third. So I pass this order inside these brackets, and the indices of the columns are comma separated. Okay, so this will display row 2 and 3. Okay, these two rows, row 2 and row 3, and the columns in the order we specified here. We stop here for today, and thanks for watching.